Hello everyone. Good morning to Ananda. This is Dr. Ananda Babu, Associate Professor, Department of Mechanical Engineering, Nadimpalli Satyanarayan Raju, Institute of Technology, Sontiam, which is situated on Anandapuram, Pendurthi Highway, Visakhapatnam. Good morning to everyone who are attending my sessions and listening my sessions in YouTube Live and recorded sessions also. Now, as you know that we are continuing this lecture on digital manufacturing from 29th, and the sessions continue up to June 2nd, that is till today. And now we are going to whatever the topics we have discussed so far, part of digital manufacturing course. Department of Mechanical Engineering organizing this digital manufacturing course in online for the benefit of engineering graduates, research scholars, and tech students, and whoever interested to do some research work or some practical hands-on experience sessions on 3D printing or additive manufacturing, so-called digital manufacturing building blocks. Myself, Dr. Ananda Babu, Associate Professor, Department of Mechanical Engineering. As you know that we have discussed what is digital manufacturing, how it is the combination of virtual reality, computer networks, rapid prototyping, and a database, and how to implement the product design, functional simulation, and the prototyping in digital manufacturing. Like that, we have discussed the various concepts in this mainstream development of direction of advanced manufacturing. And we have seen the building blocks of various building blocks of additive manufacturing, right from the augmented reality, which comes from the geometry of the object after preparation of the graphical representation of the object, and the next big data analytics, autonomous robots, cybersecurity, artificial intelligence, cloud computing, industrial internet of things, IIoT, and finally additive manufacturing. These are all the building blocks of additive manufacturing, building blocks of digital manufacturing, through which we can modify the design, and we can base it on the requirement of the component, requirement of the customer, and we can add the value to the at any phase of the production cycle. And new technologies breakthrough will help to blend the physical and digital worlds together. So by utilizing the features of the digital manufacturing, the industrialists or the academicians and whoever interested to do for any manufacturing of the components or manufacturing sector are benefited thoroughly at large scale through this digital manufacturing, which is possible, which is not possible in the conventional manufacturing. In conventional manufacturing, if you want to, there is no flexibility to modify the design and to get the scaling of to implement the scaling on the product. But in digital manufacturing, we can develop any component at any scale and and we can get the more precise and fine detailing objects, and more functional objects can be directly manufactured through these building blocks, using these building blocks, which are technologically sound. And recent era, all the building blocks of the digital manufacturing are highly enhancing day by day for the improvement of the process cycle. And we have seen the subtractive manufacturing and additive manufacturing, and we have observed the main difference between subtractive and additive manufacturing. The wastage of the material in subtractive manufacturing or the conventional manufacturing is high, and the production time cycle also takes more number of weeks or months. But in additive manufacturing process, we can modify, we can manipulate, and we can add the value to the product, final product, and we can scan the components from the physical components to the digital component, and vice versa. We can change any format from digital files to the physical file, or physical product to the digital file, using different types of scanners, 3D scanners. And we have seen the global additive manufacturing market around the globe. And in our India, we have to improve the usage of the additive manufacturing technologies in all various fields, various sectors. Right now, we are at by 2022, at 2022, we are at the market, AM market, 3 to 5% only, as compared to China, it increases more. It increases more. So we have to improve the usage of additive manufacturing in various sectors. And the key industrial additive manufacturing drivers and distribution of revenue through AM are, we have seen in mainly industrial and business machines, 20%, and automotive field, 16%, aerospace 19%, consumer goods 12%, and healthcare 11%. These are the more important playing key roles. And coming to academic institutions, the academic institutions revenue in additive manufacturing point of view is only 8%. That has to be geared up, and we will expect within one decade we will increase the usage of additive manufacturing technology in academic institutions also. And we have seen the product development cycles, where the product development cycle of additive manufacturing is less, and this cycle can be completed within weeks, as compared to the injection molding, techno conventional injection molding, it took more than weeks or months. And we have seen the additive manufacturing process chain, which starts from the design, that is the pre-processing stage, and to the processing stage and pre-processing stage, and finally process monitoring and validation, that is a quality check, quality verification or quality check. And we have seen the levels of additive manufacturing implementation right from the level 1 to level 4. Level 1 is the direct manufacturing of small components, small volume of parts from the CAD file. Through the level 4, we can add the value and offers mass customization to the new product designs. So we can reproduce at the level 2, and we can prepare the complex parts or complex designs with the adoption of the additive manufacturing, with simplify the assembly and enhance reliability. And we have seen the classification of additive manufacturing process, various classifications we have seen, and we have discussed wet photopolymerization and material extrusion process in this phase of the particular digital manufacturing course. And we have thoroughly seen the wet photopolymerization techniques, an additive manufacturing process in which the liquid photopolymer in a vat is selectively cured and hardened by light source. The light source. Those are the wet photopolymerization techniques. Are two types we have seen: stereolithography SLA and digital light processing DLP. In stereolithography, we have seen a light raster scans the wet photopolymers. The photopolymers are located in the wet, and in digital light processing DLP, the entire layer of the material of the entire layer of the component is prepared when the LED light or the light process through the projector, and the entire layer cured or hardened at once. And like that, the remaining number of layers can be rasterly scanned, and with the laser in SLA or with the light source in DLP. And we have seen the working principle, and we have seen the two approaches which are used in wet photopolymerization. Those are top-down approach and bottom-down approach. Top-down approach, bottom-up configuration. In top-down approach, we have seen the laser scans from the above. In top-down approach, the laser scans from the above. In bottom-up approach, the laser scans from the below, or the light scans travels from the below. So like that, the bottom-up approach and the top-down approach, we can utilize the source, we can utilize the configuration, whatever the configuration, but the important point is the bottom-up configuration gives more flexibility and utilize less amount of material to prepare your design, prepare your component. And we have to cure the photopolymerization products in a UV oven to perfectly fit for the component, perfectly fit for the application, which is having the desired mechanical performance or mechanical characteristics after preparation of the component. And with this photopolymerization technique, the curing of the component under when it's subjected to the light, the isopropyl alcohol is used in post-processing, but we can get the isotropic nature, isotropic properties in the component through which are prepared through this VAT photopolymerization. The benefits we have seen: high accuracy, high surface finish, and fine details can be achieved. Fine details can be obtained through this VAT photopolymerization technique. And recently, large objectives, large size objectives, or the large number of objectives are creating through this VAT photopolymerization, which are not possible at the earlier stage. And these DLP parts or ASLA parts are highly isotropic, and there is a possibility, there is a beneficial point which is happening here in VAT photopolymerization is open system for the accessible resin. Open system of an accessible resin that allows for easy removal of the material, ease of material for the development. And what bottom-up configuration uses more. And drawbacks we have seen: the support structures, the removal of the support structures, and the process are tedious and time consuming, which affects the product cycle. We have seen those are the drawbacks, and the less amount of different types of materials, range of materials also less, and strong addition of the build plate, strong addition of the layer, cured layer with the build plate also damage our component while removing the support structure. And we have seen the various range of materials and applications, right from the automotive, sports equipments, bone tissue, medical, bone regeneration, high strength applications, and surgical applications, and the strain sensors or micro actuators, and automotive, different types of functional prototyping, and jewelry and audiology, molds and casting, dental applications, and surgical training applications, and so many applications for so many applications we can utilize this VAT photopolymerization technique. And we have seen material extrusion process, second process, which is also termed as a fused deposition modeling or fused filament fabrication. And by after ending of the expiration of FDM patent, recently so many entrepreneurs or so many in industries developing this 3D printing FDM machines, and those are available nowadays. Those are available, widely available at lower price in open market. And FDM is the second most widely used 3D printing technology. And we have seen the working principle, and the coil, the resin wound to the coil is passing through the gear transmission gear and bearing gear, which is the extrusion mechanism, passes through the hot temperature, and thermal sensors are placed to identify to monitor the temperatures at the processing time and while processing. And heater is heat the solid filament, and it after heating, through heating, the solid material is semi-melted, and the semi-melted polymer material is laid down on the build platform or the bed, based on the instructions of the computer, based on instructions of the controller of this 3D printer. And we are able to see the important process parameters of the 3D printing machine. FDM are layer thickness, width, orientation of the filament, and air gap. These are the key processing parameters, and those influence the mechanical properties of the FDM 3D printing parts. And we have to observe the drawbacks of the FDM, which are called as faults, which are obtained through FDM process, and flat surfaces, Due to large flat surfaces, the warping may occur, which is one of the 3D printing fault. And to avoid that such type of things, we have to arrange fillets instead of sharper corners. And any critical shape we can produce through this FDM process, but we have to take care of the setting of process parameters, and those process parameters have highly influenced the, the appearance of the component and the production of the component and working ability of the component. Because if you are unable to remove the support structure finely, perfectly, that may damage the component, 3D printed component. So we have to take care to get the more beneficial factors from FDP. And we have seen the drawbacks. The drawbacks are the products which are produced from fused deposition modeling are having low accuracy and not having any fine details as compared to the wet photopolymerization parts, 3D printed parts, that is SLA method or DLP method. And FDM parts are having low surface finish, rough surface finish. Therefore, we have to go for the post processing also. And FDM parts are weaker in mechanical properties because of less adhesion, less cohesion or the adhesion between, less welding between the layers, because of the so many factors affects these mechanical properties. And so many numerous researchers are reported how to avoid these type of anisotropic nature of anisotropic nature developed in the 3D printed FDM parts. So we have to take care, and we have to know in NSRIT mechanical engineering department, the mechanical engineering faculty members, me and other members are keenly observing and training our students in digital manufacturing, particularly in additive manufacturing sector, which are having more bright future. And students are actively participating, and they are doing hands-on experience. And today's class we will discuss one of the project work which are done by the students, and how they get the knowledge, how they got the expertise in 3D printing of the organic structures, organic face models. And the range of materials we have seen, and applications, right from the biomedical applications, automobile applications, aerospace and aircraft industries, household applications, sports equipment, music equipment, various fields. The 3D printing is FDM machining is actually utilizing the sources, the technology, the conceptual modeling and rapid prototyping. FDM parts are utilizing and architectural models before before construction of build big projects. We can realize, we can sense how it will be appears, how it will be the taking place. We can visualize the total architectural models through these FDM parts. And marketing and graphical designs and food printing, one of the recent advancements in FDM parts. And the gallery of the 3D printed items done at the NSRIT 3D printing laboratory, mechanical engineering, which is situated in mechanical engineering, various structures, various models, mechanical components, customized components, architectural components, and human organ models, and so many models are designed and developed in 3D printing laboratory, which is located in mechanical engineering department and in NSRIT, Nadimpalli Satyanarayana Raju Institute of Technology. These are the close view of for the viewers. And now today's session, we are going to discuss about the hands-on session, hands-on experience of students, our students through project work. In this session, the last session, we are focusing in this digital manufacturing phase one lessons course duration. We are focusing on wet photopolymerization and fused deposition modeling, and how the students, our students, are mostly interested and engaged in digital manufacturing sector, and how they are introducing and how they are getting knowledge through hands-on experience and project works. Now, coming to this session is 3D printing of organic models, deployment of post-processing. Few of our students are done this project work under my guidance, and we are going to discuss how to develop a 3D printed organic models and how to process and how to post-process in order to get the clear aesthetics. Okay, we will discuss in brief. Organic model is a way of creating 3D models of living creatures such as people or animals. Now, organic models gives more value, more idea to the various fields like doctors or the teachers and so many sectors. We can visualize how the components of the human organs and animals and plants for describing the features and creating awareness among students or the aspirants. And organic modeling, on the other hand, involves mainly curves. In organic modeling, we can see the structures, the various polygons, various corners or various vertex points. But here in organic models, we are able to see it mainly involves the curves, as nature has thin against straight lines. In inorganic models, in the modeling technology, the modeling is divided into two categories. One is inorganic, and second one is organic. In organic modeling, that is the whatever the components, whatever the structures we are developing for mechanical or any purposes, except the people, the design of the people face or organs, people or animals, those are all called inorganic models. But if you consider the faces of the body parts of the organs of the humans or the animals, these are termed as organic model. So in organic modeling, we are able to design and develop, and mainly in organic modeling, the curves are involving more, and in our inorganic modeling, we are using straight lines. Because of this curves, organic modeling is usually done with the subsurfaces. Organic models place always a need to compose entirely quads of four-sided polygons. For your benefit, for your idea, we have placed this organic models, how to develop those organic models we are going to see. And various modeling softwares can be utilized for this organic modeling of human face or human organs or animals. And these are the important softwares. One, GBrush software, widely used software, which is not open source software. Blender is open source software, widely used software for the organic modeling and various purposes. And industry persons and academicians, so many persons are utilizing this Blender software and mesh mixture, Sculptrix, 3D Coat, Maya, SelfCAD, and Mudbox are the various modeling softwares can be utilized for developing these organic modeling. And in these projects, our students utilize the Blender software, which is a free and open source computer software through which we can create and animate on so many models, and motion graphics can be done, and interactive 3D applications, virtual reality, and formerly video games also we can design and develop through this Blender software. The Blender software features include 3D modeling, sculpting, animation, match moving, rendering, motion graphics, and video editing. These are all possible cases in by using this Blender software. And Blender software is a free and open source 3D modeling software developed by Blender Foundation. Blender sculpting software. This is a sculpting software which is having pretty advanced users. So many users can enjoy this sculpting habit. So many sculpting habit, and they can create any components, any parts by sketching and underlying mesh structure and conversion of 2D in their project. Our students are mainly focusing on preparation of their face in 3D from 2D photos. The conversion of 2D images to the 3D image, 3D model using Blender software. Initially, they convert 2D image into 3D image by installing the Keen Tool Face Builder as an add-on in Blender software. So before starting, before starting the preparation of the 3D model of face, we have to install the Keen Tool Face Builder add-on in Blender environment. And then we have to follow some sequence, open the Blender software, edit option, and go to preferences and go to add-ons and click on Keen Tool Face Builder, which is already downloaded from the source internet, and we have to install the Keen Tool Build software, Face Builder in the Blender software, and click on the Face Builder. And now we have to add our image. We have to add our whatever the required image and select the image from your PC or desktop or laptop, and which has to be a model. And after that, we have to see and arrange the mesh which is appears on the image. And by adjusting the mesh perfectly, we can get the 3D printed image, 3D modeling image. And this is the Blender software environment. And this is the Blender software environment. Our students utilized the open source free software, and so much data, and so many video lectures are the supporting content is available in YouTube and the internet sources. And without any hesitation, without any complexity, any student or any individual can develop and utilize this Blender software. And with little experience, with little practice only, we can create more models. We can create more organic models or any required sections, any required models. And coming to the project work, the conversion of 2D images to 3D image, they followed the steps whatever we have seen here. Adding of the Keen Tool Face Builder and loading of their students' photos and selecting photos from the PC to be modeled, and this mesh appears on the image. Now we can see the mesh appears on the image after loading the files, after loading the front photo and side photo. The students are practicing more under my guidance, and this student one, the front view of this student 2D image is this one, and side view of the student image is this one. By loading these two images and by fixing and moving the mesh structure perfectly, wherever the nose in the photo, and we have to move that mesh to that particular face. And by doing this perfect mesh mixing with the combining the mesh with the photo, we can prepare this 3D model like this. So the next students also loaded their photos, front photo and side photo, and they have adjusted the pixels perfectly, and they obtained this 3D model. And third one, student 3, conversion of 2D images to 3D images. She also loaded her front photo and side photo, and exactly, and she took more care to prepare, to adjust the mesh mixture with her photo. And by following the sequence of operations, sequence of steps, she also prepared the organic model of her face. And fourth person also did the same, downloaded their photo onto the Blender environment, and fixing their mesh mixes with their attachments, with their front photo and side photo, and following the sequence of steps to get the 3D model. She followed exactly, and she got these are all 4 students modeled their own faces with their most practical knowledge. They have studied well, they have practiced well, and they have done on their own under my guidance. And this is the 3D model of these students. After this 3D modeling, after preparing the 3D modeling, they have focused, they have turned to 3D printing component, 3D printing process, in which they have prepared their face models or bust models. We can term it as bust models using 3D printing material, 3D printing component technology. The 3D printing, they have done very efficient manner. They prepared their 3D printed face models through this 3D printed, 3D designed model through Blender software. And they have studied the process cycle of the 3D printing, right from the designing, slicing, and loading the design file into the 3D printer, and finally adjusting the process parameters as per the requirement, and in order to get the final 3D printed product. And they have clearly observed, clearly followed the workflow of the 3D printing, right from starting of the modeling using Blender software, and saving their files in .stl file format, and slicing the component. They have, as I told in last class, they have utilized the Creality slicing software, which is open source software, and they have done in our laboratory only, 3D printing laboratory only, and they have sliced their component, their 3D model, and they have clearly observes the layer slices in preview and toolpaths also. And finally, using 3D printing technology, which is 3D printing machine, future deposition modeling machine, which is situated or established in mechanical engineering department, NSRIT, and they have set different process parameters to get the fine detailed, clear face bust models of their. And they have studied various 3D printing technologies based on the 3D printing material, solid base, liquid base, and powder base, and they got expertise. They got most hands-on experience in future deposition modeling. The principle of the future deposition modeling we have already discussed. The filament comes from the spool and passing through the extruder and the hot end, and at the hot end, the filament is heated to the required set temperature. Either it is 210 for the PLA or 230 for the ABS material, and different materials having their different different printing temperatures. And they printed, our students observed this all processing of the movements and the controlling of the machine, and how it works based on layer-wise technology. And the they have studied the advantages and disadvantages of the 3D printing technology. The advantages, they felt design flexibility is high, and print on demand can be done, and strong and lightweighted parts can be prepared, and material wastage can be reduced heavily, and environment friendly designs, environment friendly production can be done through this FDM process. And they have observed few disadvantages. They have observed few disadvantages. As we discussed earlier, the range of materials is limited, and build size, different machines having their different build sizes, right from the 230 and height 250, like that. The materials, if we want to more build size, the cost of the equipment is more high. So for 230 degrees, 230 by 230 cross section, and height in z direction 280 size, the printer costs around 30,000 to 1 lakh rupees. And based on, if we want to increase the build size, the cost of the 3D printed FDM machine is increasing more, and it goes up to lakhs, 50 lakhs or 70 lakhs, or around minimum 20 lakhs, based on the build size, and the production of volume of the FDM is less as compared to the conventional manufacturing process. And next, and they have sliced the components, and they have studied how to slice the component on from the 3D model into different number of layers into individual layers. So they have utilized the creality slicing open platform, open software, and but it slices the 3D model into number of thin layers, where as we discussed it in the last class, we have to set the thickness of the layer, thickness of the walls, and like every parameter we have to set, and temperatures, material properties, based on material properties, and support structures, and this patterns, infill density, infill pattern, everything, and adhesion type pattern we have to adjust in this slicing of the component. That slicing is main important parameter to get the high resolution component, or to get the fine details of the component. And in their project work, they prepared their 3D printed 3D models from the Blender software, and they set the layer thickness, layer height, layer thickness 0.8, layer height 0.3, and printing speed 100, infill density 30, that is 30% of the material only set in the model, and nozzle temperature 210 degrees centigrade, and support structures are lines. As we discussed it, if we set the support structures as lines as the support structure pattern, we can remove the material at less effort, and the damage to the main product is can be avoided. And with this after setting their process parameters, these process parameters, layer thickness 0.3 mm, height layer height 0.3 mm, layer thickness 0.8 mm, wall thickness, that is wall thickness, and printing speed 100, and infill density 30, nozzle temperature 210, bed temperature 60, and support structures are lines, and infill density is grid. They have sliced the component, and after slicing, they came to know that their models, the printing time of those models are around 5 to 6 hours. And then they have loaded that G-coded file, which comes from the slicing software, onto the 3D printer, and the controller reads the G-coded file, and based on the instructions given by the controller, the XYZ motions, that is the bed motions, XY motions, and Z motion, that is the hot end motion, extruder motion, the 3D printing model, their face busted models are printed. And these are the various at different instances we took these photos, students took these photos, and we can see the main face structure here, and the support structure here. And this support structure is useful to get the overhanging portions, to get the clear overhanging portions. And these are the three instances. These are the three different instances of the 3D printing of their bust models. And these are the bust models prepared or the 3D printed. And it is, if you observe closely, yes, if you observe closely, some cracks, some blisterings, some defects are observed on the busted face models of our students, their printed items. And they decided, so in order to avoid these types of problems, they decided to do post-processing. They identified the different defects after 3D printing of the organic models. They observed there are different types of defects like cracks or blistering in the models. And cracks defects in 3D printing refer to the presence of cracks or fractures in their face models. They are occur due to the not properly set the process parameters, and these cracks can negatively impact the support structural integrity. Therefore, the cracks to be avoided, and they have to, for that reason, and to get the more strength component and functionally printed objects, the models are they decided to do post processing, and they studied and they analyzed the what are the reasons for the cracks. Inadequate cooling may be the cause. Inadequate cooling of the filament which comes from the nozzle may be the cause of the this type of defects. And poor adhesion between layers also, the poor adhesion between the layers also one of the reason for this development of adverse effects of the cracks. And overheating also is one of the reason. And printing speed, if we have not set the correct printing speed also, this type of defect may occur. So they observed inadequate cooling is one of the reason, and poor adhesion between the layers is one of the reason, and overheating of the filament is maybe the one of the reason, and 3D printing speed of the nozzle may be the one of the reason. So they identified the reasons for why this blistering and why these cracks happened on their face models, and later they decided to do post processing. After they decided to post processing, they have finally sanded their bust models. This shows the top picture shows the bust model of one student before sanding, and this bottom figure shows the bust model, the same bust model after sanding. We can see the difference between these two models. In top model, the warpings are, we can see some blisterings are we can see on the face of the model, and before sanding and after sanding, those are avoided. And they used the abrasive paper with the grid size of 100. And then after sanding the abrasive papers, the models are oil painted to get their appearance of the 3D models, which are converted, which are developed from the 2D images. It involves the below steps. They have took different steps for the to get as a part of post processing to get the fine detailed fine detailed, aesthetic, more aesthetic face bust models of their own. They have done paper clay. We have prepared the 3D printed bust models without hair. For that reason, they have used paper clay for designing the hair on the 3D printed model. And for that curing and for that pure hardening, it took more than 12 to 15 hours time. After that, they have applied gesso. Gesso is applied as the primer to protect and enhance the surface of the bust models. It took 1 hour time, and they have maintained the duration of the object, duration of the process, and application of oil paints. After application of gesso, after drying that component, after drying that face bust models, they applied oil paints, acrylic paints for coloring the models, and for to get the more aesthetics, and for the dry purpose, and they applied the application of oil paints to the bust models. It took around 2 days time. And some other, and they also done the application of varnish and epoxy onto the bust models. The varnish acts as the varnish acts as the protective coating for the paints from the dirt, and resin gives shiny and glossy look. So this epoxy resin gives the shiny and gloss look, and varnish protects the coating of the paints to for the appearance. Aesthetics live long for a long time. And this operation took 1 day. And in this manner, they have completed all the processes or the steps within days, within 3 to 5 days, or less than within 1 week. And these are the post-processed material, post-processed bust models after the after the applying the gesso, after applying the gesso and after application of the oil paints, you can see the difference. This first student bust model is transformed from here to here. So after adding the hair and after adding the gesso and after adding the all the paintings, this varnish, the bust model of the student one is transformed like this from this stage to this stage, and second one is transformed from this stage to this stage. We can see the clay paper added as the hair, and we have done the post processing every step, like right from the sanding, application of gesso and application of oil paintings and varnish and everything. The same product, the same candidates bust model is viewed like this. And after adding the epoxy resin, which gives the glossy appearance. So in this manner, students have designed, students have worked, and students got hands-on experience about how to utilize the 3D printing technology, digital manufacturing technology, to prepare their own faces, to sensitize, to sense their own face. And through this hands-on experience project work, they learned so much about the 3D printing technology. And I wish they got more awareness, and in future, they may turn into the entrepreneurs in 3D printing area. So after learning this 3D printing technology, and after learning this, the development of 3D models from the 2D photos and how to do the post-processing, they done every step on their own, and they have got excellent expertise on designing and development of the organic models. Nowadays, every mechanical or every structural engineer can design inorganic models, but organic models, the preparation and design and development of organic models and utilizing the digital manufacturing technology, that is 3D printing technology, for the development of organic models is considerably appreciable, and it has more strength and more value in coming future. And with the they may turn with the support of our faculty members and management and their parents and well-wishers, they may turn into the entrepreneurs in this 3D printing technology. Very soon we may see those those four girls who are working on development of the organic bust model, face model of their own. Some of the glimpses of the hands-on experience of the NSRIT students in the field of digital manufacturing or additive manufacturing and 3D printing I have shown earlier, and I am very proud and very much happy to show one more time. These are the different structures or different models our students are designed and developed in 3D printing laboratory, which is situated in the Mechanical Engineering Department, NSRIT, Nadimpalli Satyanarayan Raju Institute of Technology. And they have designed dual names, 3D statues from the 2D photos, what we have decided, what we have discussed in this class right from the starting, and 3D phone stands, 3D mementos, 3D awards, 3D tools, mechanical or structural tools, and 3D photos, 3D lithophanes, we can term as lithophanes, and different structures, architectures, both organic and inorganic manner models they have preparing and coming students. And I trust whoever joined in mechanical engineering and other streams in NSRIT, they got they will definitely experience this hands-on experience, and they learn so many things from 3D printing technology 3D printing laboratory, which is situated in mechanical engineering and makerspace also. And we have established CNC milling machine through which we are injecting the practical knowledge as beyond curriculum course, and we are establishing the applied robotics laboratory in collaboration with Andhra Pradesh State Skill Development Corporation and Aachen University, Germany. So we are having collaboration with the Germany University to establish this applied robotics laboratory in our college. This is the one and only college which got which which got that such type of favor, which type of appreciation from the government of Andhra Pradesh, and they supported us to establish the 3D printing laboratory and applied robotics laboratory with the collaboration of foreign universities and many in local and national wide laboratories and industries. And these are the various laboratory images. We are having sufficient laboratory right from the machine tools laboratory, thermal engineering, FMHM, metallurgical laboratory, mechanics of solids laboratory, workshop, CAD/CAM lab, instrumentation lab, production technology lab, theory machines lab, and we are also provided hall of innovation, that is makerspace, which is utilized to keep our students projects which will be useful to the juniors and visitors whoever visiting our campus are enjoying the after watching our students projects. And our students are doing multidisciplinary projects among our different stream students. And our department, mechanical engineering department, is established in 2009, and we are affiliating. We are the autonomous institution. We are having the flexibility to develop, to design the structure of the syllabus based on the for the industrial needs, and so many industrial persons and so many industrialists, experts from the various industries, national level industries, and we are taking suggestions and guidelines from the international resource persons and industrial persons also. With the combination of academia and industry, we are designing our syllabus, and we are training our students towards the practical exposure and hands-on experience. Right now, we are offering mechanical engineering department offering two programs, UG program with the intake 90 and PG program, thermal engineering with the intake 12. And we are having sufficient faculty members and sufficient doctorates. Myself, one of the doctorate, Dr. Ananda Babu, and we are having sufficient laboratory structures, laboratory facilities, and faculty members, and we are training our students. We are sharing our knowledge, and we are injecting our exposure and experience into the students' minds for their career growth and for their bright future. And NSRIT offers various programs: civil engineering, computer science engineering in artificial intelligence and machine learning specialization, and computer engineering in data science, electronics and communication engineering, electrical and electronics engineering, mechanical engineering, and MBA also providing here. And we are giving more, we are sharing more knowledge through practical exposure and theoretical explanation into the students' mind. Our students are encouraging and entrusting their knowledge and enhancing their technical skills in their practical life. And they are doing internships at different zones, different areas, different industries, right from the second year onwards. After completion of their second year, second semester onwards, our students are doing industrial summer internships. And after third year, second semester also, they are doing summer internship. After second year, second semester, they are doing industrial summer internship 1. And after third year, second semester also, they are doing industrial internship 2. And in final year, in our autonomous structure, our students are continuously one particular semester, they are focusing and they are doing their project work and they are learning as full-time in their various industries. And we are also offering other programs, regular BTech program, honors and minors with the transdisciplinary education, and with the most important thing is industry linkage, and industry persons are regularly visiting our campus and giving their valuable suggestions or guidance to our students through career guidance cell. And these are the references which I took from the various sources, right from the YouTube, right from the Google, right from the textbook. And with this, I'm concluding my session. These are all 4-5 days sessions. We have discussed what is digital manufacturing, how the additive manufacturing is the building block of digital manufacturing, and what are the advantages and applications of digital manufacturing in various fields, various areas for various applications, and what are the basic additive manufacturing technologies we have discussed. In future, we will discuss the remaining additive manufacturing technologies. In this course, in this phase, we have discussed the VAT photopolymerization technology. Under that, we have discussed stereolithography, SLA, and digital light source process, digital lights process, DLP. And under material extrusion process, we have discussed fused deposition modeling and their applications, and mainly how our students are involved in digital manufacturing, that is 3D printing technology, additive manufacturing technology, and how they are developing various inorganic and organic models, and how they are getting knowledge or expertise or exposure in 3D printing by doing their project work as hands-on experience sessions, complete one semester sessions. And we are also engaging our students in various aspects, technical trainings and industrial trainings, and right from the second year, and industrial internships and industrial linkages. Our students, mechanical engineering department students and other stream students are continuously getting support from the industrial persons and experienced academicians and well-known eminent persons in AP and in nation India. So with this, I'm concluding my session. I am thankful to everyone who are watching my videos, and we will see in future, we will discuss in detail about other additive manufacturing technologies. Until then, goodbye. Thank you, everyone. Namaste.